So as I was saying in the previous video, which again I got cut by the timer, I'm sorry about that. The rocks that are mostly affected by this acid rain, that is again going to travel through either surface water or groundwater, are going to be evaporites, which are rock salt or gypsum, or rocks of the family of the carbonates, which again are composed of calcium carbonate or calcite, and those are going to be limestone and dolostone for the sedimentary rocks and their derivatives, and marble for the metamorphic rocks. Okay, so the reason why they get the most affected by this acid rain is simply a chemistry or a chemical reaction, which I will explain to you in the next slide. And again, as you're seeing here in this image on the top right, this is sort of the development that you're seeing for the caving of the system underground. So you're seeing that it's basically eroding all the rock underneath, it's weathering it out, and eroding those particles as it does so. And of course you're going to get some sort of empty space, and then by the weight of the overlying ground, it's going to collapse. So that is how that karst topography forms. I was saying also that in this image on the bottom right, this is an extreme case of karst topography. Right now you're just seeing this hills. So you think that maybe they're being weathered away on the top, but in truth, this used to be all kind of flat lying ground, and the top of the ground used to be the top of what are now those hills. So you can see that all the material in between those hills and those knobs has been completely weathered away by this dissolution process. So this is in China. Pretty cool. I've never been, but I've seen several pictures and they're all just absolutely beautiful. So if you can make it down there, definitely go. And also from the previous slide, this one, these sinkholes that we see, this is in Kentucky, and they are famous for the amount of caves that they have down there. So if you're ever around, definitely check them out. Okay, so as I was saying in the previous slide, when you have this dissolution, it's due to a chemical reaction. So you're seeing here the chemical reaction, that specific one, or the chain of chemical reactions. So initially, you're going to have carbon dioxide in the atmosphere, which is going to react with water vapor, or clouds, basically. That is going to form that carbonic acid, that H2CO3. That carbonic acid, once it precipitates as rain or snow or hail, whatever medium, is then going to react with the calcium carbonate that makes up the rocks. And then that reaction is going to give you basically bicarbonic acid and a calcium ion that is separated from that molecule. So by doing so, you're breaking up that limestone and you are just splitting up the molecule. So you're no longer going to have what makes up the limestone itself, that calcite component of it. So as you're seeing in the two pictures below, one of them is showing you a caved system, the one on the right, and then the one on the left is actually showing you kind of like water passages, water paths that are being taken, and as they go, they're weathering the surface. So you're seeing all these rails that have been weathered by the water on the surface. The one on the cave is probably weathered by groundwater. So this type of dissolution is going to lower the surface if there were to be collapses, somewhere between 10 centimeters and 100 centimeters every year. So of course it has to be in extreme cases where you have 100 centimeters a year subsidence due to this type of process, but it can happen. So whenever you have limestone that or marble or whatever it may be that is susceptible to this acid rain, you are for the most likely going to have this type of karst topography. This slide is pretty self-explanatory, but it kind of gives you an idea of how the process goes. So whenever you have any groundwater traveling through cracks and faults within the limestone beds or the marble or the dolostone beds, that water that has again some carbonic acid within it is going to start dissolving the rock. As it does so, it's going to create larger fractures or even caverns where those fractures used to be, those weak points. And as it does so, it fills up those specific holes that it just made. If the water were to be drained, if the groundwater level actually drops, all that space that was then dissolved is now just empty space. It's air that is not being occupied by either solid or by liquid. And so by being just air, it's very susceptible to get land falling pretty much on it, right? So as you're seeing in the picture sequence, pretty much whenever you have groundwater dropping, you're now going to have this cave that is no longer filled. And with that, all the sediment above is likely to collapse and fill in that gap. If it does collapse, then the surface feature that is formed is going to be a sinkhole, as you're seeing it on the image on the top right or on the bottom left. So a landscape that has many sinkholes is going to be a karst topography, karst plain is going to be the specific term for it. Okay. This slide here gives you kind of a progression of how the karst topography forms. As it says, the dissolution is going to be greatest in fractured rock. That is because there is more surface area for the water to do its weathering job. So if you have either physical or chemical weathering, the greater the surface area, the more weathering that there can be. So whenever you have fractured rock or folds within the rock, all that area that was previously exposed to other parts of the rock is now being exposed to the elements. So either air or water in this case is going to be the main driver for weathering. So as you're seeing in the progression, the first thing is that the caves are going to begin to form. So whenever there's fractured rock, water flows through there and it does its dissolution job. It's going to continue to dissolve through any of the cracks that were previously formed. So you see that this one, for example, is now filled in with all this water, and the water is starting to actually fill in any of the perpendicular channels that have, or fractures that happen in that specific rock. And then the groundwater level drops, and now all those all those spaces where the water used to flow through are now empty and just filled with air. So because they're not filled with anything, they're not very resistant, and whatever overlying sediment or rock that there may be a lot more likely to collapse on top of them. Okay, so now I'm going to show you just a progression of different pictures of cave systems and just karst topography overall. So the diagram on the left here is just another representation of how this karst topography forms. Initially, as you're seeing, you just get some caverns underneath, and the groundwater is almost all the way to the top, so there is no potential for collapse because the water is impeding it. Then whenever the groundwater level drops, you're getting that empty space for the ground to collapse. And you get further surface water dissolution as well, so you start getting some tower karst on top. You get caverns that are now collapsing and making sinkholes, and you also get that tower karst. The furthest you get into this cycle, you're going to create pretty much the whole system is going to be all tower karst, and still you get some dissolution going on underground beneath where you have that limestone rock. Another example, and this is a true example, not just a diagram, is this beautiful lake in Croatia that is 290 meters in depth. So that's how much erosion or dissolution, weathering there has been due to the acid rain reacting with that limestone. And then on top of the lake, on top of the surface, there's another 530 meters of weathering that has been ongoing. So probably what happened in this specific place is that there was some groundwater that dissolved the rock underneath. There probably was a sinkhole that further on collapsed once the groundwater level dropped, and then there was further dissolution as it collapsed. There was more surface water accumulated where the sinkhole occurred, and there was further dissolution, to get what you are seeing there on that picture. So on this picture right here, you're seeing just a bunch of those sinkholes being filled up with surface water. So you're seeing that it doesn't help that they form, because later on the surface water accumulates on top of them and it just drives the cycle over and over. So it's a positive feedback loop that you are getting there. So here is an example of that tower karst. This one's again in China. I think that's the only place that has the massive tower karst that is very notorious. This is just a cavern, some cavern features, some cave features that you're getting. So if you've ever been to caves, you'll see stalagmites and stalactites, which are features caused by the water inside of the cave. So it's going to be water either dropping from the top of the cave and then accumulating basically the sediments at the bottom, and then those building upwards. So that's going to be a stalagmite. And then the stalactite is going to be that same water flowing from the top, but leaving residue of its flow hanging from the top from the roof, I should say, of that cave. And so those are going to be the stalactites that you're seeing. So again, stalagmites is going to be something like this, where water accumulates, leaving some of the residue on the bottom. And stalactite is going to be something like this, where the water, as it flows, leaves some residue behind. Okay? So these are just more features of them. You're seeing a cavern right here. And of course, water running through it, or on the bottom. You're seeing some features in this smaller kind of waterfall. You're seeing that underneath each of these steps, there is dissolution going on. Also down here, you're seeing that that stream is actually going just fully underground. So it's a disappearing stream like we saw in this diagram over here. You're seeing more cave features. These are just cool slides. You should take your time and pause the video if you need to look at them any further. All right, and now we're on to our next topic.